have yesterday on your perfect squares? Is that long enough to do all 25? I really think it is. But, I'm not going to do that to you. I'm not doing that to you. So instead, I'm going to give you the full 2 minutes. I'm going to give you a full 2 minutes, but that includes Abby Grace writing her name. So when I press start, that includes the time for her to write her name. And so it said, well, I'm just going to write this back. If I can't read your name, we got a problem. So, and you can just put 18 somewhere. Okay, so if there are more words not coming out, if for some reason Eric just can't remember 17 squared, he's trying, but for some reason 17 squared is just beyond him. He now has enough time where he could probably do 17 times 17 on his paper. I think you missed that word, the golden wisdom. So worst comes to worst, Eric forgets one. He can do 17 times 17 on his paper. He can probably do that pretty fast. He probably can. But, does he have time to do 17, 18, 19, 20, 21, 22, 23, 24, 25? No. He has time for maybe 1 or 2. He does not have time to multiply all of them out. But if for some reason Abby Grace's blanks on 1, she can multiply it out. She has a little extra wiggle room. Okay, let's go over it. We can get out there. I know, I got tons of it. Let's go over it. What's 17 squared? 18 squared? 19 squared? 20 squared? 21 squared? 22 squared? 23 squared? 24 squared? 25 squared? Okay, tell me 23 squared again because you made me nervous. Okay, and you're still making me nervous about it. So make sure that was the one you got now. If you want to stare over it while I finish passing out these papers, that's fine until you get it.
It was supposed to be 4.
Is it? I give it to you.
Okay. All right.
I give it to you. When I'm in doubt, I tend to be on your side. It's not a bad thing.
Are we doing this on the back?
No, we're not doing anything on the back. I just figured you wanted it back. We're not doing anything on the back. We were just going over it to get it out of the way. So now we're going to go ahead and get those math workshops out of the way if you don't already have those out, and we're going to go ahead and get the little bit of notes we're going to do today out of the way. Then we'll spend the rest of our class talking about you and your checkpoint and your quiz tomorrow. Okay. I'm going to break her heart right now. Okay, so let's go ahead and get those math workshops out the way. I'm looking for a volunteer for number 9. Some group want to volunteer for number 9 on the math workshop. Yes, table 2, that was fast. Go ahead.
Number 9 is
It is a function. And you get a point for that. Number 10, Travis.
No.
What does it fail? What is that called? Yeah, I call it the pencil test. The proper name is vertical line test. And look, it fails it here, and there are lots of other spots where it fails at. So it's not a function. Number 10, and you get a point for that. Travis, number 11, yes, dear. Yes, dear.
no.
It's not a function. It fails that vertical line test at lots of places. It's not a function. Then we get to number 12. And let's go with Brady because your group hadn't talked yet. Go ahead. It is a function, and you can have a point for that. This is not something you have to know. This is just something I'm curious about to see who knows what, and it's fine if you don't know the answer. There are specific kinds of functions. So far we've talked about linear and nonlinear. I'm looking for a word. It's not quadratic, but something quadratic, cubic, some sort of other word to describe this graph. Does someone know the name of the function that describes this graph? It's fine if you don't. First and second didn't. This is not linear because of that turn.
Quadratic? Can you say it?
Quadratic is number 9. Wait, it looks like parabola. It's an absolute value function. Just wanted to know if you knew. It's an absolute value function. It's fine. Okay, and then let's go to number 13. That's no one's known all day. It's fine. Table 2. Okay, so yes, it's a function. Okay, same question. You might not know what kind of function. Just want to know if anyone does. It's fine if you don't. Again, all you have to know at this point is linear, nonlinear. Okay, it's a square root function. Just so you know things. It's nice to know things in life. Okay, so those were easy. You've got function, not a function when it is a graph, that is for sure. Then we get to 14 through 17, and we've got to put it in standard form. Go ahead, dear. Put it in standard form on number 14.
4x plus 3y equals 7.
Okay, so some people are needing me to show the steps based off the questions I got 0 period. So if you need to show the steps, and so 4x plus 3y equals 7, I'm not going to be mad at you. I was just trying to save time yesterday. It's not a problem. Okay, can you, in order to get the complete point, can you tell me the A, B, and C?
A would be 4, B would be 3, and C would be 7.
That is correct, and you can have a point. Okay. Yes, dear. Travis, I'm going to save you for a second. Yes, dear. Will you do number 15?
8x plus 6y equals 7.
How did you do it? Tell me what you did. That is correct. But tell me what you did.
Subtracted 8, and then I
Okay.
and then I divided by 1.
Okay, so he's thinking like me. I move over the x's, so I have negative 8x minus 6y plus 7 equals 0. And then he takes a whole nother step to move the 7 over. And he has negative 8x minus 6y equals negative 7. And he's like, oh yes, we had a rule yesterday that said that a value, let me say that again slower. He moved the x piece over. Then he moved the number piece over. And now it's technically in standard form, but you can't have, Travis, I'm already going to give you a point for it. Just wait a second. Let me finish my rant. You can't have a negative a, so he went ahead and multiplied everyone by a negative 1, and you changed it to 8x plus 6y equals positive 7. Are there any questions about that? Can you tell me the A, B, and C in order to get your complete point?
A is 8, B is 6.
Yes, that's fine. And now you get your point. Okay. There has been someone every class period who is apparently smarter than me, because I totally would have done what Landon did. I would have moved over the x's, moved over the number, changed everyone's sign, and there is a better way. And you know it too, don't you? Yeah. So the easier way, so you can do it like this. Heck, maybe Abby Grace wants to be different and multiply everyone by negative 1 to begin with. As long as Abby Grace is following rules of math and she ends up with 8x, 6y, and 7, I don't really care what she did in between. But an easier way is if you realize, hey, x is by himself over here. If I just add 6y to both sides, I'll have 7 equals 8x plus 6y. Well, my goodness, that's the same thing as 8x plus 6y equals 7. So Travis really only had to do one step, just move the y over, and he realized, hey, as long as I have the x's and y's on one side, the number on the other, it doesn't matter that they're on the right and it was on the left. It doesn't matter. And he's right, and if you understand that, his way's easier. If you don't understand that, me and Landon are cool with this. We still end up with the same answer. We end up with A is 8, B is 6, C is 7. It's up to you. Travis, I know you gave yourself a point for that, right? If not, you should. Okay, then we get to number 16. Yes, dear.
Is it x plus 2y equals 20?
Yes, it is. How did you do it?
Oh, I multiplied it all by 2.
Okay, so first period did this, second period didn't. If you did not multiply by 2 first, it's fine. It's fine. It's just an idea he had, which is not a bad one, of, hey, if I multiply everyone by 2, that fraction's going to go away super fast. So I'll have 2y equals negative x plus 20. And then he said, hey, that x needs to be on the right side, so he added x to both sides. And he had x plus 2y equals 10. In order to give you the full point, can you tell me what the A, B, and C are?
A is 1, B is 2, and C is 2.
Perfect, you get your point. Someone last period broke my heart. What did they say A was?
0.
They said A was 0, and they freaking broke my heart. But they got it together now. Yes, dear.
It's supposed to be 20.
And this is how Brady gets him a point, because Miss Compton did not distribute well today. 2 times 10 is 20. Miss Compton couldn't do math. Miss Compton already failed her own test. Yay. If you can find it and fix me, you can definitely get some points. Because if you thought I was perfect, you're wrong. Okay, 17 is another doozy because of all the fractions. Sure would be nice if we could kill them off at once. Yes, dear.
Multiply by 8.
If we multiply everybody by 8, all the fractions will die. Why is it better to multiply by 8 than to multiply by 16 or 32?
Smaller number.
The smaller the number, the better. The smaller the number that goes, the better. 8 goes into 8. 8 goes into 4. 4 goes into 8. It all works out perfectly. Okay, if we distribute that 8, Brady probably did this in his head. He did not write this next line, and that is fine. 5 times 8 is 40. 3 times 8 is 24. 24. Negative 9 times 8 is negative 72. That is supposed to be a 4. In fact, I can't stand it. It is a 24. Brady didn't write that step. And that's fine. Again, in Algebra 2 Trig, if you know what you're doing, it's not bad to show work. I like work. But if you knew it was already going to reduce to 5x equals 6y minus 72, well then good for you. Oh. Brady, you want to finish it out so I can give you your full point? Okay, and I have 5x minus 6y equals negative 72. What is the A? What is the B? What is the C?
A is 5, B is negative 6, C is negative 72.
Perfect, and you get your point. Okay, we agree we did a lot of math workshops today. Why is that? Yeah, we want to catch up and we have a quiz tomorrow. I don't want to do any math workshop tomorrow. I want to save 18 and 19 for Friday. We're not doing any of these tomorrow. I'm not saying we're not going to do math. I'm just saying we're not going to do math workshop. Okay, moving along to our notes for today. So far, we've talked about 2-1, which is the function, not a function part. You seem pretty good, but I see, because I never checked to make sure you did those 4. How am I going to know you didn't do those 4? When you miss it on the quiz. True story. Okay, and then 2-2, we talked about linear, nonlinear. And I left you some problems that were in standard form and asked you to rewrite them and identify A, B, and C. You just showed me you could do that with the math workshop, so I'm going to let go checking those 2. But again, Zaylin, it might not pick on her. She's being quiet, but she does her work. If Zaylin hasn't practiced these on her own, she's not going to suddenly pull off a miracle and get them right on the quiz. So just because I'm not checking it doesn't mean you shouldn't do it. Okay, and then we talked about how I stink and I can't copy. So this is where we're starting today. But we already did the back of this because it was 2-2. Whoops. We are going to do 5 minutes worth, maybe? Maybe? Okay, so it makes sense. We talked about functions, not a function. We talked about linear and nonlinear. And once you start talking about linear stuff, you know the next thing you're going to talk about is slope. So today we're talking about rate of change and slope. You have a nickname, right? Because you're called Drea, but your name's Andrea. Isn't that correct? Andrea. I can't talk. You know that. Okay, so Andrea and Drea represent the same person, right? Rate of change and slope, same math concept. They are talking about the same thing. So even though we're going to say rate of change today, it's synonymous with slope. Okay, and I know you can read, so I'm not going to read to you. But I am going to point out what we're going to do is find the change in y divided by the change in x. Does that not remind you of the slope formula where you do y2 minus y1 in the numerator and x2 minus x1 in the denominator? And then for those of us who just love math and can't get enough, in pre-cal and especially in calculus, we're going to call the rate of change delta y over delta x. So just don't be surprised. In calculus especially, they love to turn everything into Greek letters. So delta y over delta x means rate of change. Okay, the first example stinks because the words are underneath. It says the table over here shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So our first column with the time is the x's. Second column, temperature, that's the y's. To find that rate of change, we're going to need to find the change in y and divide it by that change in x. Okay, so let's look at the x's. They're easier. I'm increasing by 2. I'm increasing by 3. I'm increasing by 3. And then I'm increasing by 4. Okay, and that was easy. The harder ones are the ones on the right with the y's. So 143.6 minus 139.4. I'm going down, so it's negative 4.2. I subtracted 4.2. Okay, 133.1 39.4. What did you get for the next one? For a point. Brady, you get a point. And then on the next one, what is this? It's still going down, so it's going to be negative 6.3, but yes, and you can have a point. And then the last one. Say it again. Thank you, dear. And you can have a point. Okay, so we live in math class. And in math class, when we're working math examples, everything tends to work out oh so perfectly. Because the math teacher made it. So what we're about to do is going to work because this is linear. The reason I know this is linear is because when it increased by 3 in the x's, it decreased by the same amount in the y's. So this is why I know it's linear. Now I'm going to point that out now, just so Eric understands. If he willy-nilly sees a table on the ACT, he cannot automatically do this rate of change. Rate of change is only going to be this kind of a thing if it's linear. And of course, the math teacher is giving you all linear examples right now. So I need you to actually consider it when you see it in real life. But for today, life's going to be perfect. So Eric is not really paying attention today. He's not. So he goes home and he's like, I really don't remember what on earth Miss Compton was saying. But hey, she said it was the same as slope. So maybe I can use that slope formula. So he goes home and he does 139.4 because he's saying that's y2 minus 143.6 because he's saying that's y1. And then he does x2 minus x1, so 2 minus 0. He works that out, and he gets negative 4.2 over 2. And what does that reduce to? 2 point what? 2.1. Perfect. And then I'm going to break Eric's heart, because yes, that is the correct answer. But Eric is doing way too much work for today. That's too much today. He doesn't have to do that much. But when Eric goes home and he forgets, this is what Eric's going to do. And he's going to end up with the right answer. But we said rate of change is change in y over change in x. So my change in y was negative 4.2. My change in x was 2. I would have gotten negative 2.1 anyway. Or let's say I used a different change on the graph. Maybe I did negative 6.3 divided by 3. Hey, that's also negative 2.1. Or if we did the last one, I bet it's also going to be negative 2.1. Unless we can't add today. It should be negative 2.1. It's 8.4 right here? That's what I thought. I knew there was something wrong. So if we did it, it still would be negative 2.1. So we can pick any change in y, and as long as we're using the corresponding change in x, we can figure this out super duper fast. Okay, so are there any questions about that one? Let's go on to the next one, and it's going to be so fast, you're going to be excited. What is it changing by on the axis? It's plus 2 every time. That's nice. It's consistent. What's it changing by on the y? Table 1, you helped me the most with that. You can have a point. It was Caitlin, I believe. Okay, and then, so I know the answer from here. I don't have to use slope formula. I know the answer. Does someone know the answer? Yes, dear?
1 or 6. No.
Isn't it just 6? Isn't it the change in y divided by the change in x, so it's just 6? So if you said what he said, he's flipping it and doing change in x over change in y. So he has the x's in the numerator. Do we put x's in the numerator when we're doing slope? No. Yes, dear?
So time is always been split. Is there another measurement?
Time tends to be x, or something that we depend on in life. Well, yeah, I mean, yeah, lots of other things could be x. Don't you hate it when your brain goes blank, but you know there are thousands of other examples? I'm like, there are thousands of other examples. Thousands of other examples. We could do the assignments you've done. Assignments completed could be x. And then your grade could be y. Because let's face it, the more assignments you've completed, the higher your grade is. So there are lots of other variables that could be x. It tends to be, when we're trying to make it real world, it tends to be time, because everything tends to depend on time. Because the amount of distance you run depends on time. The temperature of the room depends on time. The amount of people in the auditorium might depend on how long it is since this concert began. Everything in life depends on time, so we tend to pick time. But no, time is not the only one. Good question, add a point. Okay, we get to number 3, and it is confusing. Why is number 3 confusing? Thank you, dear. Because of the time issue. So I'm going to pick right here on the table, but seriously, we can pick anywhere. What is it increasing by right here? What is it increasing by over here? What's my answer? 10 over 2 is 5. But let's say Xavier doesn't believe me. He didn't like that spot. He could pick down here. It's increasing by 10 minutes. Over here, it's increasing by 50 people. Well, 50 divided by 10, isn't that also 5? So anywhere you pick, it's going to work out, because Ms. Compton has made perfect linear examples. Yes, dear?
So the line on this graph goes straight, correct?
Yes. It's going to be a linear, only, yes.
Is that the only thing? You can do this with a curved line?
No.
You can't?
Nope.
What would that be called if it was a constant curve?
It's still going to be called rate of change, but you know we don't calculate the slope like we do. You don't have like a y2 minus y1 formula, do you? We've never talked about one, so no. We're still going to call that rate of change, but we're not going to treat it the same. It's not going to be this easy. It's not going to be this easy. Okay, we've got 2 more, and Ms. Compton's done talking about new math. Lickety split. I know you can do 4 and 5. I'm going to pick right here on 4. I'm going to pick up here on 5. Again, it doesn't matter where Sarah picks. She's supposed to get the same rate of change every time using the same chart. So that one's going up by 8. That one's going up by 3. I don't know what's going on with these. If you've got the final answer, that's what I'm looking for. And you get a point. Okay, so this one, 28326 minus 25430, you get 2896. Well, 2896 divided by 8 is 362. But seriously, if Xavier picks anywhere on that chart, let's say he didn't do between 15 and 23, he did the rate of change between different points, he's still going to end up getting 362. And if this was a test, would it be smart to check it out with a couple of different spots? Yeah. Okay, and then on the last one, on number 5, I need the answer for it. Yes, dear? And bless you for knowing it was negative. Okay, so since we're going down, it's going to be negative 7.1 because we're decreasing. We had a bigger distance, we went to a smaller distance, so it's decreasing. And if we take negative 7.1 and divide by 3, we get negative 2.3666 repeating, so I'm going to say negative 2.37. Again, this is not supposed to be a complicated section. If you'll just find the change in 2 y's, divide it by the change in 2 x's, you have an answer. Yay. For being alive? Oh, yeah. Sorry. Yes, for that. Yes. Okay. The good news is we're not going to talk about this anymore today. The bad news is I want to talk about that checkpoint. That checkpoint. That checkpoint. You are. Well, let me say my words and you will end it. Okay, I'm going to break your heart right now. I am straight up going to break your heart right now. Well, actually, I'm probably going to make your day. But it breaks my heart. So I'm in a hurry in life, as is our usual lately. And we must take that quiz tomorrow in order to be on time, not be further behind in class. Which means this checkpoint has to be finished today. Which means, and there's no way, when most people didn't turn it in yesterday, it means there's no way it's going to happen. So, the good news is
You love us.
that I love you and you're getting free 10 points for this checkpoint.
You're the sweetest, Miss Thompson.
If you don't have a checkpoint, it's in the yesterday's date, 8/29.
That's why you're my favorite.